So good afternoon, everyone. Thank you for coming. So my name is Tahir Mahmood, and I would be presenting ImWeb. It's a cross-platform immersive web browsing for online 3D neuron database exploration. So let me start off with a little bit of introduction. So among other various tools, web interface is a common platform for exploring large data sets. These tools provide means for exploration, keeping in mind the domain-specific benefits. And an important example of these data sets include 3D neuron database that we use in our system. So these databases provide ultra-scale high-resolution images of neurons to help in the research related to neurology, computer vision, visualizations, etc. These available data sets promote exploratory research and interdisciplinary collaboration. For this specific project, we used neuromorpho.org. It's a available free source database which have a lot of 3D structures of neurons, high resolution images. So let me describe some limitations with these databases that we have. So first of all, the design of these web interfaces obviously focuses on very specific users who have specific needs. It's hard to design a layout that fit various needs, but also an overcomplicated web design trying to meet all diverse needs may overwhelm the user with too many options. Secondly, so far web browsers do not have powerful capabilities of 3D visualization and interactions compared to like standalone 3D systems, which are optimized for various functions, including specialized 3D rendering and interaction with those. So thus, we believe that web alone cannot provide complex and adaptive exploration functionalities for 3D database and 3D structures. I'll pause for a few moments and show you a small video which would explain a little bit about our system, and I'll come back to the slides. I'll pause on over here and play the video while we complete the presentation. So before heading into the details of our system, I'll just briefly touch upon some related work in immersive analytics, cross-device techniques, and augmented reality browsers. So first off, immersive analytics is obviously extending classic desktop environments into AR and VR. For example, among others, Mahmood and colleagues used immersive visualization using AR to investigate the abnormal events in heterogeneous multi-source time series data. And similarly, people are taking advantage of stereoscopic capabilities of virtual reality for immersive visualizations. Secondly, a lot of previous work has focused on cross-device techniques, including work GRASP, where authors combine large touchscreen displays with spatially aware mobile devices. And similarly, Huang and colleagues combined smartwatches with touch displays for visual data exploration. This technique saves user from always holding a mobile device like tablets but limits the number of unique interactions the user can do. So it's a trade-off. Thirdly, I'll talk a little bit about augmented reality browsers. So a lot of recent work has been towards developing augmented reality browsers. It's also worth mentioning some low-cost AR browsers which use smartphones for augmenting 3D content. And recently, Firefox released Firefox Reality, which is a 3D or AR version of their browsers for the users to view and interact with 3D models. So our system, ImWeb, which is immersive web browsing, we combine augmented reality with web browsing. So it provides a flexible architecture to adapt different needs of users without changing the hardware structure a lot. So the first component is the web, which is used to access large database hosted on servers and integrate intensive computing component through the servers. Secondly, we used augmented reality. In our case, we used Microsoft HoloLens for the 3D visualizations of the Neuron contents. It provides enhanced depth perception, multimodal interactions, including voice, hand gestures, and gaze, and also gives the ability to use the large physical space around you for rendering the 3D content. So our design is motivated by a design study which helped us define our design goals. First, we provide a set of visualization and interaction techniques based on the context where we combine web and AR. So first, we provide hybrid visualizations which are used to enhance the web browsing experience for the user using visual cues in augmented reality. And secondly, we allow users to perform exploration and comparative tasks on 3D neuron structures. Finally, we combine both AR and VR interface so that user can interact with both the interfaces or either one of them. We achieve this by using flexible networking frameworks for web interface so that user can query neuron structures, and the server obtains the results and provides neuron structures that have neuromorphological similarities with the query neuron, and then finally we use AR to visualize the structures. I'll briefly go over some of the design goals that we discovered. So first of all, we want to facilitate a variety of input integration for mixed multimodal interaction, because integration of web and AR offer challenges for interaction between the two paradigms. So we not only want one unique way to perform an interaction, rather we want to give the user a variety of ways that they can interact with the system. Second goal is that we want to facilitate a variety of information integration methods to provide an intelligent, personalized visual interface for the user. And this is based on from user's focus and the object of interest that the user has. Thirdly, we want to provide a variety of cross-platform exploratory analysis tasks aimed at different users and their requirements. So in the basic architecture of our system is to allow users to explore individual neuron structures, and they may also query the neuron structure of interest to find structures which have neuromorphological similarities between them. And this is a web interface, image of a web interface of our system. So we have Vuforia image markers which help AR devices like HoloLens recognize the location of the web interface, and so that HoloLens can position the 3D structures on top of these images so that it gives a good view to the user of like visual cues for the user. So the user can input the 3D neuron that they have interest in, and they can search similar neurons based in the data set. And the method that we use for querying similar neurons, we use deep learning algorithms to query similar 3D structures from the database using feature vectors to represent all neuron sets in the database. And to make it easy for the user, for AR devices to render those 3D objects, we actually use shape preserving. We use binary coding to compress the neuron features while preserving its main structure. To give you an example, the first two images on the top are the actual neuron based on the files that we get from the neuromorpho, and the bottom two images are a little compressed and versions that we use which has less complications, and it's the structure is preserved, but it's easy for HoloLens to render the object. As mentioned previously, the immersive visualization and interaction techniques in our system, we first use the hybrid visualization for the web. It generates visual cues based on the state of the web interface, and it shows additional information to overcome limit of the web interface. And the main idea is to enhance the original web interface without changing much of the structure. We provide immersive visualization and interaction with the device, and most of the interactions are usually a combination of users' gaze, hand gestures, and voice commands for intuitive and immersive interactions. We provide 3D manipulation of the neuron structures, which include rotation, translation, and scaling. The interactions using the user can also interact with the system using AR, which send the query results to the web interface and get the results back. So you do not have to depend on both of the interfaces to interact with the system. And finally, we provide a few exploration and analysis tasks. First of all, neuron structure exploration. The system provides miniature 3D structures which are overlaid on top of the query results in the web interface. So the user can use the web interface or either AR to interact with the system to query more results or explore the current structures. System also keeps track of the user's exploration history so that they can revisit the history in the later stage of the analysis process. We also provide effective visual comparison methods to explore similarities between the structures. So the user can interactively color the branches of the structures to show the similarity between them. And system intelligently positions and scales different or multiple structures while the user is comparing them, so that when the user places them in the physical space, they are not overlapping or cluttered. Finally, to help the user gain a better understanding of the whole analysis process, we provide summary visualization, which is a high-level report of users' explored data sets and structures. It helps piece together all the insights into a compelling whole, and system visualizes miniature 3D version of these structures. So our system basically works with multiple devices with different sizes. So we have tested our system with large screen displays, desktop environments, and iPad tablets. The idea is to demonstrate the flexibility of the system on most frequently used displays and variety of intelligent interactions for different tasks. As mentioned earlier, devices are basically recognized using Vuforia image markers to detect the size of the display. I'll briefly go over a small case study, sort of, to describe the usage of our system, but I'll also show you a small video after this. So consider like domain experts in neurology exploring the neural structures and trying to compare them. They can start off by exploring the structures based on their needs or the structures that they find interesting in the database, and they can visualize each structures using AR, observing them closely and rotating them, scaling them, doing manipulations. Using voice commands, user can switch to a comparison mode where they can visualize the structures to view their morphological similarities. User can interactively color different branches in the multiple neuron structures to visualize their similarities so that they can view them and confirm the results. And user can cluster them based on their similarities and their classifications. Finally, users can switch to a summary visualization to revisit the earlier interactions for a sense-making task. We actually performed an informal study, and the goal of the study was to assess the combined immersive approach of our AR plus web interface. The study was performed with 8 college students in computer science department, and users were asked to explore different neural structures, compare them, cluster them based on their similarities. As a result, most of the users appreciated the system and the idea to combine AR and web, because we do not need much structural, we don't need to make much structural changes to the web interface. And the users frequently used the voice commands and observed structures closely and moved around them. We found that some users preferred observing the structures closely and moving frequently, while others stayed at a distance and used interactions and manipulations like rotating and scaling. We also provide some experts' feedback from 2 experts in neurology department. They said that the ImWeb provides a new avenue for neuromorphological analysis for 3D AR. And the web system is easy to access and it's easy to use and works with different device sizes. And secondly, they suggested that the embedded interactive mining algorithms automatically computes analytical results for the user, so that's a good advantage. And the AR application brings new perspective for neurological analysis. They also made some suggestions, some useful suggestions, and they believe that more immersive analytics tasks should be included and some better mining algorithms to improve the runtime. And some device-related suggestions, for example, better field of view for AR devices, including HoloLens, some better performance, and including some more interactions. Finally, to conclude, we combine web and AR in our system. Web is used for hosting and browsing large data sets, while we use AR to visualize 3D content. Our approach basically overcomes some of the previous mentioned limitations and allows users to browse perceptually effective 3D renderings using augmented reality. We provide multimodal interactions, and the design is intelligent and intuitive for the user to use. For future work, we want to include or improve our system using multi-user interactive collaborative systems so that 2-3 users can collaborate using the system and can share results and brainstorm. And we want to integrate more immersive analytics tasks. I'll continue with the rest of the video.
Different colors of color palette. This process
Thank you.
So we have time for questions.
Hello. Thank you for your talk. I really like your interesting idea to use the AR to do visualization. So I just have one question about the visualization here. So what's the reason that you choose AR over VR or even what we call fake 3D? So we know that you can render the 3D image on the 2D plan and you can still work on that, select it, choose the color or something like that. So is there any reason that you use AR here over those two other technologies?
Sure, good question. So the reason why we chose AR over VR or other technologies is we wanted to combine augmented reality with a web interface so that we can augment the use of web interface-based neuron databases. And it gives the idea is not to change the hardware or the web interface too much and augment it using HoloLens or augmented reality systems.
I will follow up with this question. What about the solution with two displays? I mean, one which gives the traditional web interface, another one which allows 3D interaction, navigation, and so on. You know, you can use two displays with connected views.
Yes. So they are basically connected. You can interact or query neurons using HoloLens.
No, I mean without HoloLens. Why you chose HoloLens instead of using two displays with connected views?
Because with because 2D interface, 2D web, 2D displays, you won't be able to visualize 3D structures in a much effective manner. It doesn't provide immersive viewing of those 3D structures, and it's one of the limitations that we mentioned in the paper that web browsers are not very good at visualizing 3D content for users to understand them in a better way.
Because there are many 3D libraries where you can create 3D models, you can navigate, and so on.
Yes, but again, you're only limited with a small size and a limited size of the screen. But compared to HoloLens, you have a better physical space around you. So as a canvas, so you can place them, and you don't have to switch between screens. You just move your head around, and you can go back to the results again. So it's have a better space for you to visualize.